Alright, so if you do calculus for any length of time whatsoever, eventually you're going to come up upon the mean value theorem. So, what is the mean value theorem? What do we use it for? And most importantly, how do we use it? Well, mean just means average, right? So, this can be thought of in simpler terms as the average value theorem, which really gets at what we're doing with it and what it accomplishes. So, just like everything else in calculus, it initially looks insurmountable and difficult and too complex to master, but it's not. It's very simple. The sole purpose of calculus is to save you work and make you have to do less math to get a more precise result than you could with previous maths. So, let's look at the technical definition of the mean value theorem, or a semi-technical definition, which says, if f of x is continuous over a to b, and notice this is a closed interval, if f of x is continuous over the closed interval a to b, and differentiable over a to b, the open interval a to b, then there is C1 a to b such that f prime of c equals f of b minus f of a over b minus a. It's a mouthful. Let's break it down. If f of x is continuous over a to b, closed interval, so we first know that when we're given an interval, an x and a y point, and we know we have to work in between this interval, if it's not continuous, if there is an asymptote in the middle of it, or if this is our function and we come up and we have a discontinuity there and then we start here and there's an asymptote, if it doesn't work. You can't do it unless it's continuous. So that's just one thing to know off the bat. If it's not continuous, don't bother doing any work. You're not going to get a useful answer. And differentiable over the open interval a to b. We say that because if we had it as a closed interval, then it would have to include certain numbers or certain constants on each side, which you would take the derivative, you just get a horizontal tangent line, it wouldn't work. So, or it would be differentiable, but it wouldn't be differentiable in a good sense. So that's why we have an open interval there. So if it's not continuous, throw it out. If it's not differentiable, throw it out. So if it is continuous and you can take a derivative of it within that interval, then you're good to go. So it says if both of those conditions are met, then there is C1 a to b. So that just means at least one point within a to b, such that f prime of c equals f of b minus f of a over b minus a. All of this is just saying the slope of the lines connecting the endpoints. So let's look at a graphical representation of all of this. So this is a graph of f of x. This green line is f of x. It's our function. The numbers here don't matter. This is just explaining what it looks like on a graph. And don't confuse yourself with values. So we have an arbitrary value here at a. We have an arbitrary value here at b. And this is what's eventually going to be plugged into your function. A is this point on f of x, b is this point on f of x. A corresponds to a, f of a, and b, f of b corresponds to b. Well, it makes sense, right? A is your x value, obviously we just said that, and f of a is you're plugging it into the function to get your y value because a function looks like this. Y equals f of x. So our x point is our x point, and our y point is f of that point, right? Okay, pretty simple. So, green line is f of x. We have 2 points here, a and b. This is our interval that we're provided. If in the problem, let's say this could be 2, this could be 7. It could be anything. So this is the interval we're provided with. Here is c. Here is a point that we put in the middle, and we want to say, okay, let's use this point to determine what the average derivative is of all of this. So this little squiggly orange line here just simply refers to the average derivative in between these 2 points. So that's basically saying we have a whole bunch of speeds. The height of the line here represents speeds. We have a set, and we have small speeds or big speeds followed by medium speeds, and we just want to know, hey, what's the average speed? That's what this is saying. All of these are representative of this set within this little interval, and we're trying to figure out what the average derivative is if we took the derivative of an infinite number of points along that line. So you could do it the hard way, and you could pick 10,000 points along that line and take the derivative of all of them. Okay, that sounds pretty miserable, right? And you're still not going to be perfectly accurate. You're going to have a margin of error. If you use the mean value theorem, you won't have a margin of error, and you can take the derivative of an infinite number of points with one simple formula. So now that we understand basically what we're talking about and how it looks on the graph, let's go over here and talk about the steps of how you do a mean value theorem problem. There are 3 steps, and they are all relatively simple. The first step is just take the information you know and plug it into the formula we talked about. Say f of b minus f of a over b of a. Okay, so you're given a function. Let's say our function is f of x equals x squared. Then this is just going to be b squared minus a squared. It's just wherever you see an x in your function, you're going to plug in a and b when you're evaluating for f of that function. Make sense? Good. So on the bottom, b minus a, you're just going to take the numbers in your interval. So if our numbers in our interval are 17 and 4, then this number is our a, and this number is our b, so it's just going to be 4 minus 17 in the denominator. None of this is important now. All right, so we get that, and we get our answer. And we just put our answer off to the side. Great. The second step is to take f prime of c and set that result to the answer we got from step 1. So you take the derivative of the point at c. You're given your point, or you're given the function that tells you what c is. You just take the derivative of that function. Let's say that, let's erase this really quickly so we have some room. Let's say that in your function c equals x cubed. Then all you're going to say is x cubed prime equals, and if we know our derivative rules, this should not be hard, 3x squared. And so you're going to take 3x squared as your derivative. You're going to plug in the appropriate value, and then once you have what c prime is, you're going to set that equal to this. You can't plug in a value yet because you don't know. So in this case, we're going to have the answer from number 1 equals 3x squared in this pretend problem. So the answer from number 1 simply equals, in all problems, f prime of c. So we set these things equal to one another, and we solve. That's the third step. We've solved. Great, we're done. Let's say that in a pretend problem, we got radical 3 over 2 and 84 as valid answers. Okay, that's great. Both of these might be right, or both of them might not be right. One of them might only be right. You have to look at your interval and get rid of things. So if your interval was 1693, then you know that radical 3 over 2 has to go away because it's much smaller than 16. So you kill this, and you only keep the values within your interval. So, basic overview. The mean value theorem is a way to find out the basic derivative, the average derivative of a function over an interval. This is what it looks like on a graph to do that for a pretend function. This is the formula you use to represent that. The steps are to calculate that formula with the interval points that you're given. Take the derivative of your c point, or the arbitrary point you're given in the middle of those two values, and then set those two answers equal to one another from the calculation of the mean value theorem formula and your derivative f prime of c. Solve that and keep only the values within your interval. It's just that simple.